Okay, we're going to continue our lesson on radians in chapter 4, section 1. In this section, you will find coterminal angles, convert decimal angles to degrees and minutes and seconds. Let's talk about coterminal angles. For example, if it is 1 o'clock now, how many hours must pass before it is 3 o'clock? So 1 o'clock now, 3 o'clock, the obvious answer would be 2 hours, right? Are there any other answers that can make this true? What about 14 hours, right? So you can go 2 hours, you can add 12 more hours, it will be 3 o'clock again, right? That would be 14 hours. What about adding 12 again? In 26 hours, it will be 3 o'clock. It was 1 o'clock now. In 24 plus the 2, it will be 26 hours. It will be equal to 3 o'clock again. And then 38 hours, adding 12 each time, because that's how many hours it takes to go around the clock. And 50 hours and so on, right? So these are called coterminal hours. We can talk about them as angles in a second. But are there any other ways to get coterminal hours? Are there any other ways to get to 3 o'clock from 1 o'clock? Well, if you had a time machine, you could go back in time minus 12 hours. So after negative 10 hours, it would be 3 o'clock. And then after another negative 12 hours, it will be negative 22 hours, it will be 3 o'clock again. And negative 34 hours, and negative 46 hours, and so on. All these are minus 12 hours because that's how long it takes to go all the way around the clock. Okay, so that's kind of a basis of our coterminal. From yesterday, you remember that the place where the angle starts is the positive x-axis, and that is the initial side, and the terminal side is where the angle ends. In this case, pi over 6 radian degree, or radian measures. When will it be pi over 6 again? Well, if we went all the way around, we could get back to here again. So that means we could add 2 pi to my pi over 6. In order to add 2 pi to pi over 6, we have to have a common denominator. So that would be 12 pi over 6, which is 2 pi. Now we're going to add pi over 6 plus my 2 pi, which is 12 pi over 6. We're going to get the coterminal angle of 13 pi over 6 is equivalent to pi over 6 because we've gone around the circle one full circle, or 2 pi. Okay, what about a negative one? Give give two coterminal angles, one positive, one negative. Now we're going to give a negative one. So that means we're going to have to go the other way. So if we're going to go the other way, we're going to subtract 2 pi. So in order to subtract 2 pi, we get a common denominator, 12 pi over 6. 6 pi minus 12 pi over 6 is negative 11 pi over 6. And you notice that if I add these two together, I will get one full circle, or 12 pi over 6, which is equivalent to 2 pi. Okay? Let's try a different one. Give 2 coterminal angles in radians, one positive and one negative. So here we have a positive 5 pi over 4, because we know 4 pi over 4 is 1 pi, and that's half a circle. So another fourth of a pi will get me down here. How do we get another coterminal angle that's equivalent to this red line here from this black one? Well, if you add another full circle to it, add 2 pi to that, get a common denominator, which is 8 pi over 4, to add to my 5 pi over 4, we'll get 13 pi over 4 will be another angle that's positive, that's equivalent to this. So both of these angles will end right here, starting here. Terminal side here, initial side here, terminal side here. All right, now if we went backwards, a negative angle going this way, we would subtract 2 pi. If we subtract 2 pi, we would subtract 8 pi over 4 from 5 pi over 4 and get negative 3 pi over 4. So this angle right here is negative 3 pi over 4, and this angle is positive 5 pi over 4, and together they make 8 pi over 4. Together, the positive one and the negative one make one full circle. Okay? Alright, so now we're going to convert these, convert 15 degrees, find 2 positive coterminal angles and 1 negative one. So another positive one would be adding 360 degrees. So that's going to give me 375 degrees. It's the same thing as 15 degrees. There's one. Then we can add another 360 to that, adding another full circle, and we're going to get 735 degrees. Okay, and now we want a negative one. A negative one, we're going to subtract 360 degrees from that, and negative 360, 15 degrees, and we're going to get negative 340 degrees, because negative 340 plus 15 is 360. So there are my 3 angles. Okay, let's see here. Let's do it with this one. You finish this, see if you can get it. Okay, I want 2 positive and 2 negatives. Ready? Alright, so I'm going to add 360, and I'm going to get 655. That's one, and then I can go around the circle one more time, and that will be 1,015 degrees. That's another one. And that's equal. This is plus 360. Okay, and then to subtract 360, we're going to get, let's see, that would be a 6, negative 65 degrees would be my negative one. Now let's do one for our radians. So now we're going to add 2 pi, and that 2 pi with the common denominator of 6 would be 12 pi over 6. That's my 2 pi, and that will give me 13 pi over 6. Doing that again, add another 12 pi over 6, and I get 25 pi over 6. Subtracting a 12 pi over 6 from 1 pi over 6, I will get a negative 11 pi over 6. Okay, you do this one here in radians. Did you finish? Alright, so I'm going to add 2 pi, which is really 6 pi over 3, common denominator. This is 2 pi. And I get 11 pi over 3. Doing it again, I get 17 pi over 3. And subtracting 6 pi, I get a negative 1 pi over 3. What about this one? This is 2 with no degree symbol. That means this is in radians. So what did you get? Did you finish? All right. We're going to add one full circle. One full circle is 2 pi, and 2 pi is really, since this doesn't have a pi on it, it's really 6.28, because it's 3.14 times 2. That'll give me 8.28. Adding 2 pi again, I'm going to get 14.56. Whoop, let me do this here. We're going to add 6.28, and that's going to give me 14.56 radians. Subtracting if I were to subtract 6.28, I would get a negative, right over here, negative 4.28, lining up the decimal so that we can subtract. All right. That's how you get coterminal angles. Coterminal, co meaning together, together terminating in the same place. All right. If we have a measure in degrees, 1 full degrees is like hours, and parts of a degree is in minutes, just like parts of an hour in minutes, and parts of minutes are in seconds. And the ratio of these for degrees is still 60. Remember, degrees is from some kind of weird, strange division of the circle into 12 pieces, and then divided those 12 pieces into smaller pieces. So the minutes are 60 minutes in 1 degree and 60 seconds in 1 minute. So if we want to convert 3 hours, 3.5 hours into hours and minutes, we have 3 hours, and half an hour would be 30 minutes. Well, we're going to do this is how we do that. We take the 3, take that apart, and then put 5 over 5 hours, 5/10 of an hour. This is 5/10 of an hour times 60 minutes per hour, so that we can cancel the hours and multiply the 5 times 60 and divide by 10. We get 30 minutes. If we take degrees, we'll pretty much do the same kind of conversion. We're going to take the decimal portion of it multiplied by 60. So we take the degrees part, the whole number part off, take the 0.76, multiply that by 60, and we get 46.8 minutes. Well, this decimal part can be multiplied by 60 again to get 48 seconds. So we have 3 hours, or 35 degrees, 46 minutes, and 48 seconds. Okay, let's do one more. Okay, we're going to write this in minutes and seconds. So we write down the 48, take the 60, and I'm going to do it this way because the PowerPoint kind of confuses me. Okay, so we're going to take the 48 degrees, and then we're going to take this 0.62 of degrees and multiply that by 60 minutes per degree, and we're going to get let's see, 37.2 minutes. So it can write 48 degrees and 37 minutes, and then the 0.2, we multiply that by that's in minutes, multiply that by 60 to get seconds, so that will be 12 seconds. Okay, hope that makes sense to you, because we're going to take that 48 off, put the 0.62 times 60, we get 37.2 minutes, and then we can take the 0.2 off and multiply that by 60, and we get 48 degrees, 37 minutes, and 12 seconds. All right, you're going to complete this for your homework. There's a PDF you can download, print that out, and fill that in, or you can just draw this table yourself. And once you get that, you're going to complete this. I gave you degrees, you know how to convert that to radians, and then you're going to find the complements and supplements. I'll do one for you here. If the supplement was 140 degrees, the original angle, the supplement to that, should have been, they have to add up to 180, so it should have been 40 degrees, because these two add together to give you 180. Now 40 plus what number gives you 90? This would make this 50 degrees. Okay, converting 40 degrees to radians, we multiply that by pi over 180. Pi radians over 180 degrees. The degrees from the numerator and denominator cancel. I can reduce this by 20, and I get a 2 and a 9. So this will be 2 pi over 9. Converting the 50, doing the same thing, 50 degrees times pi over 180 degrees. The degrees cancel. And I can reduce this by, looks like 10. And this will be 5 pi over 18. And then doing the same thing for 140 degrees. Multiply that by pi over 180 degrees. The degrees cancel. It looks like 20 goes in here 7 times. 20 goes in here 9. So it'll be 7 pi over 9. Okay, so there's going from one spot to another, you should be able to fill this table out. Only one piece of information is needed to complete this. Okay, so just to show you one here, I know that these two have to add up to pi over 2, because pi over 2 is 90 degrees, so then this has to be pi over 4. And then what plus pi over 4 will give me 1 full pi? That should be 3 pi over 4. Or you can subtract 1 pi. If you take 1 pi minus 4 pi over 4, you'll get 4 pi over 4 minus 1 pi over 4, and then you're going to end up with 3 pi over 4. Converting these back to degrees, you have 3 pi over 4 times 180 over pi. And the pi's cancel. And then 4 goes into 180 45 times. So 3 times 45 will give me 135 degrees. Okay, so you should be able to finish this table. All right, that's it.